Welcome to this explainer. Today, we're unpacking a defining moment in modern space exploration, one that literally changed how we approach the incredibly delicate boundary between human ambition and unforgiving physics. We are going to uncover the overlapping failures, both mechanical and organizational, that led to the tragic loss of the Space Shuttle Columbia and its 7 crew members.
To really wrap our heads around this event, we have to start right in the middle of the tension, on the morning of February 1st, 2003. Columbia was re-entering Earth's atmosphere after what seemed like a highly successful 2-week mission. Down at Mission Control, capsule communicator Charlie Hobaugh was just doing a routine tire pressure check. He radioed up to the shuttle. On the other end, Mission Commander Rick Husband began to reply, but his transmission was abruptly cut off, ending with this chilling, unfinished sentence. There was no further answer. Just minutes later, debris began raining down over Texas.
Okay, let's dive into this. How exactly did the 28th routine flight of the Columbia Space Shuttle program end in such a devastating tragedy? For NASA, you have to remember, this was supposed to be a completely standard operation. The shuttle was part of the Space Transportation System, built entirely around reusability, and Columbia was a veteran spacecraft with 27 successful missions already under its belt. The answer to its failure, as we'll see, lies in a terrifying chain reaction of overlooked details.
Section 1. The physical cause.
It's a terrifying contrast in scale, really. You've got the Space Shuttle Columbia weighing well over 100,000 kilograms. Yet the physical catalyst that doomed the shuttle before it even left Earth's atmosphere was a piece of foam weighing just 750 grams. This piece of insulating foam, which was roughly 60 by 40 centimeters, so think about the size of a standard briefcase, separated from the shuttle's external fuel tank during liftoff.
Now, what's really interesting about this slide is the sheer velocity of the impact. In the vacuum of space, or just sitting on a desk, a 750-gram piece of foam is completely harmless. But during launch, the extreme forces of acceleration turn something that lightweight into a deadly projectile. That small piece of foam struck Columbia's left wing at incredible speeds, somewhere between 700 and 900 kilometers per hour.
This timeline really puts the whole tragedy into perspective. That catastrophic foam strike occurred a mere 81 seconds into the launch. Yet, the crew spent the next 2 weeks in space completely unaware that anything was wrong. They just went about their 15-day mission in orbit, totally cut off from the reality that their heat shield was hopelessly compromised for their upcoming re-entry on February 1st.
Section 2. Ignored warnings.
You know, a physical strike is rarely the only cause of an accident of this magnitude. So let's look at the systemic, organizational breakdown. A couple of days after the launch, proactive NASA engineers actually realized the potential danger. They requested that the Department of Defense use American spy satellites to photograph the shuttle's left wing to assess the damage, but NASA management flat out denied the request. Why? Because historically, foam strikes had been seen on 65 previous missions. Actually, think about that for a second. 65 times. Management had basically normalized the deviance. They fell into a dangerous psychological trap where they viewed recurring flaws as standard, everyday maintenance issues rather than critical safety threats.
Following the disaster, an internal commission was formed called the Columbia Accident Investigation Board, or CAIB. When they released their massive report in August 2003, they explicitly cited NASA's negligence. Specifically, they pointed out human spaceflight chief William Reddy, who failed to accept that offer to use spy satellites. Because that offer was ignored, the extent of the damage was never investigated while there was still time to potentially attempt a rescue or repair.
Section 3. Re-entry and disintegration. Let's move to and see how this builds, breaking down the highly technical mechanics of the crash, step by step. So, that initial foam strike had punched a small hole in the wing. As the shuttle began its descent, the intense friction of Earth's atmosphere caused that hole to expand. Superheated air started leaking inside the wing, completely compromising the thermal protection system. This pressure then caused a piece of insulation as big as a suitcase to break off. Suddenly, Columbia's internal structure is exposed to external fire and plasma. The sensors in the left wing failed first, and then the structural integrity of the wing rapidly tore the ship apart. And here is the truly heartbreaking part. The crew was completely oblivious to the impending danger until the absolute final moments. At 8:58 a.m., Columbia's backup flight software suddenly displayed alerts regarding tire pressure loss on the left side of the shuttle. This was just 1 minute before the signal to Earth was permanently lost. It was the very first indication the 7 astronauts had that anything was wrong. In the aftermath, of course, questions swirled about the crew's final moments. To provide some clarity, we can look briefly at the 2008 Columbia Crew Survival Investigation Report. It is really important to clarify that the crew did not suffer prolonged exposure to heat or fire. As the shuttle disintegrated, cabin pressure was disrupted instantly, meaning the astronauts lost consciousness within seconds. The report concluded that the hypersonic entry conditions were simply not survivable, even with advanced equipment.
Section 4. The human element.
We absolutely have to honor the crew and the groundbreaking scientific work they were conducting. And this brilliantly illustrates the immense value of their mission. The 7 astronauts worked 24-hour shifts, alternating schedules to conduct over 80 continuous experiments. They studied microgravity combustion. They grew 3D prostate cancer spheroids to better understand tumor behavior. And they even facilitated experiments designed by schoolchildren globally to see how spiders, bees, and ants react in space. Thankfully, because data was constantly beamed back, roughly 30% of this invaluable research was successfully transmitted to Earth before the disaster.
Now, amidst the total destruction, investigators found a pretty wild anomaly. Live roundworms, housed in specialized aluminum canisters and petri dishes, actually survived the intense heat and impact of the Columbia crash with only minor heat damage. It's a small miracle, really, and in a beautiful nod to the continuity of science, descendants of those very same surviving roundworms were actually flown into space years later on the Space Shuttle Endeavour mission in 2011.
So, what were the lessons learned? The loss of Columbia forced a profound reckoning at NASA. The agency hit pause on the entire Space Shuttle program for 2.5 years. During that time, they took the harsh lessons of the CAIB report to heart and completely redesigned the foam ramp on the external tank. And those rigorous systemic and engineering overhauls successfully prevented this specific type of failure from ever repeating across the remaining 135 total STS missions.
To truly grasp what was lost, we have to remember the visionaries aboard. One of them was mission specialist Kalpana Chawla, the first Indian origin woman in space. Her journey from a small town in India to the stars serves as a massive inspiration. This quote from her perfectly anchors the emotional weight of this explainer. When you look at the stars and galaxy, you feel that you are not just from any particular piece of land, but from the solar system. It reminds us of the brilliant human lives dedicated to expanding our shared horizons.
Ultimately, the Columbia disaster wasn't just a failure of a foam heat shield. It was a failure of a system to recognize its own vulnerabilities. As we plan massive new missions to the Moon, to Mars, and beyond, the story of Columbia stands as a critical monument. It begs a vital question. Will we remember the harsh systemic lessons of Columbia as humanity pushes further into the solar system? It is a stark reminder of the incredibly delicate balance between our boundless ambition and the absolute necessity of rigorous, unwavering safety. Thank you for exploring this with me.